Hello and welcome to another episode of the Kielder Observatory podcast. I'm Ian Brannan. Alongside me once again is Director of Astronomy Dan Pye. And in this episode, which we're recording right slap bang in the middle of summer at the end of July, heading into August 2023, we're marking the return of astronomical darkness, because in the northeast we have some fairly light nights actually, and now we're starting to get that darkness back, and we're heading into a section of the year, one of the most exciting parts of the year for astronomy. But also we want to shine a light on some of the other places that you can go to do some stargazing. And so in this episode, actually, we've headed out of the studio and we're doing a bit of stargazing in the podcast, but also talking about plenty of other stuff that's coming up and things that you can see in the night sky, even without a telescope, just by looking up in this fantastic part of the year for astronomy. So without further ado, we'll head out to our location, somewhere in the north. We're on top of a hillside. We can see for miles around. It's just starting to get dark. We can see the moon, and it actually looks like we are on the moon where we've parked, because it's a barren wasteland. Where have you brought us to?
It's a place nestled between Waskerley Station and Edmunds Byres. It's Edmunds Byres, actually. I find that a really hard word to say, Edmunds Byres.
Until today, I'd never actually heard of it, so I'm not familiar with the pronunciation.
It's over there.
It's that place over there. And it's very nice. Is that the one that's got a little bit of it looks like it's got some beautiful buildings, looks nice and remote.
It's very remote, yeah. And then over there you've got Concert, and then over there Sunderland, I think, is probably that place that you can see in the distance over there.
Yeah, I would say that probably is it. Yeah, and the maybe Durham, that direction, Sunderland beyond, and we can also see the red lights twinkling in the distance, and that would be of I reckon that's going to be sort of Hartlepool area. That'd be the wind farm, wouldn't it?
I'm not sure, actually. I was looking at those lights just before there because I was trying to work out what they were, because, of course, these ones over here are Pontop Pike and Burnmoor. What do they call that one? Burnhope.
Yeah.
But that one over there, I don't know. Yeah, that could be the...
Yeah, I think that's the wind farm at Teesside.
A long way away.
Yeah, so that's 30, 40 miles or so, at least, as the crow flies. So one of the points of this podcast is to, well, really, first of all, talk about the fact that we're leaving the midpoint of summer behind us now. And for an astronomer, of course, the summer presents obvious hazards in that clearly you can see less. We are right next to a road, by the way, so you will hear the odd car come by. There he goes.
Do a competition. Guess the car.
Well, I didn't see it. I didn't see it. What was it? Well, I can play. Was it a Mini? I didn't see it. I averted my eyes. So we're moving away from the mid part of summer. Of course, here in the northeast, and for many people across the whole of the UK, but particularly in the northeast, doesn't really get dark fully at night. And so now we are starting to head back in August to the point where we do get a little bit of proper night.
Yeah, and that comes back for us in the northeast from the 5th of August. It's already there for the southern parts of the UK. Cornwall have had it since mid-July. So guess the car.
Looked like a
Hyundai.
Yeah, it was. It looked like it was Korean or something like that. But yeah.
Yeah, so that came back for Cornwall mid-July, and then it gradually creeps up the country as we start to go around the sun, and we'll get darker skies returning from the 5th of August here in the northeast, and then a little bit later for Scotland. Scotland will head into mid-August for when their dark skies come back. Certainly the tips of. But that means that with the dark skies returns, when the moon's not out, then this time of year is when the Milky Way is perfectly orientated, almost right above our heads, at about, just after midnight. So it's a great time to get out and get looking for the Milky Way as the mid to the back end of August.
Yeah, and that is one of the real highlights certainly for astrophotographers, but also astronomers in general, because it's not every part of the year where we get to see the Milky Way. It is an amazing photograph. We don't get the full effect here certainly in the northeast, do we? I think you've got to go a bit further south, maybe even down to Europe and Spain or France or somewhere like that, where you get the full view. But we get a little glimpse of it.
Yeah, we do, and we can't see right down into the core of the Milky Way, but we can kind of see right on the tip of the core, if you like, just as we start to get into that really bright section. But yeah, if you're going on holiday to places like Spain or Tenerife in particular, then this time of year when the moon's not out, so when we start to get into mid-August, that's going to be a really good time of year to go up places like Mount Teide and have a look at the Milky Way from there. And I remember when we went there in 2019, even when the sky was blue like it is right now, there's still quite a lot of blue in the sky, you could see the Milky Way coming out at this time. And it's because the atmosphere is just so dry, so still. You're quite high up as well, and it's incredibly free from light pollution. So it's a great place to go see it.
Here, of course, there is a little bit of light around. It's not totally in the darkness like you'll get at Kielder. But another thing to talk about is how really you can sample the night sky and get a great view of things like the Milky Way from so many different places, particularly around the northeast. You don't have to go to Kielder Observatory itself to get that view. You don't have to go to Northumberland. You don't have to go to Kielder. We're proving that right now because we're on the outskirts of County Durham, well, in the middle of County Durham, and not totally out of sight of light, but here is a place where you can see the Aurora, you can see the Milky Way and all of these things, and it's not too far away, not too remote for a lot of people.
Yeah, absolutely. And the funny thing is, when I go to different places across the northeast, people say to me all the time, "Oh, Dan, it's on my bucket list to go and see the Milky Way." And I think, really? You literally have free access to this when the moon's not out. If it's a clear night, you can just whiz out into places like here, less than an hour's drive away in most of the northeast, and you can go and see the Milky Way. I think it's amazing that people have that on their bucket list and have free access to it, and they're not using it.
And it's totally free. You just need to get your car up here or get a lift up here or whatever. Hopefully you can get somebody to bring you back if that is the case. It's pretty remote. There's no buses. But yeah, there's no entry to it. There's no entry fee. We are just on top of a hill. Yeah. And of course the sky is there. Clearly you need a clear night, which we don't fully have at this moment in time, I've got to be honest. But it's all there to look at. You don't need to go on a sort of an organised trip to be able to do this. What is it?
It was
a golf.
It was a golf.
It was a golf. an older one, I'm going to say. I was confused by the shape.
Yeah, you're right. We don't have to go to these places far away to enjoy the night sky. We're very fortunate in the UK, actually. There's a lot of places that you can go to escape light pollution, even across the rest of the UK. And a great place to find out about your local place to go to is of course, the International Dark Sky Association's website. I think it's darkskies.org. And it's a great place to go and find out about your local dark sky accredited place. But you can also, if you Google light pollution UK or light pollution map UK, that'll show you where is dark around you as well. And just escaping the mass areas of incredible light pollution and surrounding yourself sometimes with a horizon as well. So if you find a place which is dark near you, just try and gather yourself in amongst some trees that you can see almost vertically above your head out of. And that really helps stargazing straight up above your head. And if you just lie down on the floor, and you'll have an amazing view of the sky above you, I would imagine, in places like that. And of course, try and avoid the moon.
Yes.
Yeah. So
we do have half a moon this moment of recording this tonight, which is getting increasingly brighter as the skies get darker. We mentioned about the Aurora. It is something, as you say, many people have on their bucket list. We're entering Aurora season again as we get through August into September, particularly. Tell us about how you're best looking at that. And we've covered it many times, but explain where we're at in the Aurora cycle first, and why this year might be better than last year for it.
So we're starting to come up to the peak of the solar cycle. So this means this is where the sun is at its most active. So it's producing lots and lots of sunspots. That's to do with the internal, the magnetic field that surrounds our sun, which punches holes in the sun and creates these big flux loops that snap and release material towards Earth, and that's what stimulates the aurora. That's the aurora in 3 sentences, I think. Probably could have said it better than that, but that's all right. That says it. So then when we get an indication that aurora is going to come, what we want to try and do is find a place which has a really good northern horizon, like here. We've got an amazing northern horizon. We're really high up, and actually I just checked on my phone there just to see how high we actually were, and I wasn't sure if this was higher than the observatory, but it is. It's an extra 100 metres higher than what we are at the observatory. We're nearly at 500 metres here. Right. So a great place to get a really good northern view, and there's little light pollution over there as well. You want to try and get places where there is little light pollution towards the north, otherwise you're going to get fake aurora, which is going to be a city. And then when you get the notifications either on your phone or somebody's screaming about it on Facebook, go to your favorite website, or a really great website to use is the Glendale Skies Aurora website, although it gets bogged down sometimes because it's getting quite popular now and it tends to break or he stops access to it. But that's a great place to go and figure out whether or not it's worth getting out to go and see aurora, because it'll show you who near you has seen aurora. Out you go, find yourself a hill with no light pollution towards the north, and hopefully you'll get to see some aurora activity. It is quite faint though. So when you see it for the first time, it's not always immediately obvious, and sometimes it's better to use your phone now, actually, which is a really good way of figuring out if you're looking at aurora. I noticed this with my phone earlier on in the year when I just had it on. When I had it on camera mode, I could see the aurora just on the screen live. And then I could take photographs, or I actually took a quick video as well, just because the phones are getting so good now at capturing low light images. So that's a good way of verifying it. You're looking for the lovely straight pillars rising from the horizon, and then the greens and reds and pinks and stuff that's associated with aurora.
And so people should be aware that maybe it might not be quite the mind-blowing experience that you imagine when you first see the aurora. It looks better on your camera than it might do to your naked eye, and you might not really feel that that people imagine what it's going to be like, and they're going to get all these colours dancing over their heads, but it might not necessarily be quite like that to your naked eye. Yeah,
definitely in the UK as well, I think that's the case, because if you go to places like Sweden, Norway, Finland, Iceland, it's going to be a lot more, it's going to be higher above your head. So you're going to have it right above you. It's going to be very intense compared to what it is in the UK. And you might get some colour stimulant out of that. It might be greens that you see. But in the UK, it's not going to look as the photographs portray it. It may look black and white, a kind of ghostly thing on the horizon.
Because we're looking at it from still a distance off rather than it being directly over us. So it's
that's it. Although saying that, earlier on in the year when it was really kicking off, that last really good show that we had before the darkness left, that was pretty high up. It was almost above us. So that was a really strong display. So we can get occurrences where it does come right down the country. It's just that they're less common, but as we start to get into solar maximum, we might see some more really strong activity like that. Fingers crossed it's clear, though.
Okay, so worth just popping your phone camera open and seeing what it looks like on your phone screen. Not something you would previously have advised, I think, a few years ago, because I was always like DSLR cameras and RAW mode and all that, whereas now iPhones, for example, the new ones, the cameras on there can detect it. I think iPhone cameras do have a RAW mode now, I think, don't they, as well?
Yeah, they do, and it's funny because I bought a new camera and I bought a new lens, and I'd spent all of this money, and I thought, actually, why have I spent all of this money? Because my camera on my iPhone is the thing that I'm going to end up using the most here. So I'm trying to force myself to use that camera now. But I think it's interesting, because a few years ago I would have been like, I need a DSLR to get the images that I want to get. Whereas now your iPhone can do such a great job.
Yeah. Oh. 2 cars back to back.
They were
One for the thrill seekers.
racing. That was 2 Fiestas. I think.
Yeah, that's the choice of the sports car driver. So that's one to look out for. And the Aurora is going to be this sort of next burst of energy, I suppose, where we see it at this time of year, coming up from when into August through September.
So when we start to get the darkness back, but as soon as we get into the equinox, around the equinox, so 23rd of September, when we get to the autumnal equinox, is when we're going to start to maybe see some more activity of Aurora. In fact, the equinox is always the time that we get the biggest influx of material, the biggest influx of activity, and there's still a little bit of uncertainty around why that is, but we do notice that we get more likelihood of aurora around the equinox for sure.
And you don't necessarily also have to go to a big hill in the middle of the country. Coastal areas are equally as good, aren't they? If you can get somewhere pretty dark, St Mary's Lighthouse, for example, Whitley Bay being one, people have seen it as well. I think it's South Shields around there, further up the coast.
Suffolk.
Suffolk. If you fancy it, obviously it's quicker to go to Bamborough and places like that. You fancy, but anywhere sort of northeastern, looking at where you get out away from the land, I suppose, where it juts out a bit.
Yeah, for sure. If you get a north-facing view from the sea, then that's a good place to go and see it. But also through August, we have the Perseids as well coming up. Which the Perseids doesn't have a moon this year.
Does it not?
No.
This is exciting news then. Now, the Perseids being meteor shower, if you're not familiar with this, happens every year around the same time, doesn't it? Obviously, but with no moon, that's sort of the magic you're hoping for, to see these shooting stars.
Yeah, it is, because that means you have an increased chance of being able to see the dimmer ones, because these things are very small. When we're talking about it's tiny little bits of material burning up in the atmosphere, which are like maybe less than a millimetre in size, up to a ball bearing in size. Although they are quite small, of course, when they're coming through the atmosphere, they're moving very fast, very rapidly heating up the gases around them, and that's what makes them illuminate. So we need no moon in the sky to see a good amount of them. And that is what we have this year. And dark skies will be back then as well. So fingers crossed for the 2 week, because there's a 2 week period either side of the peak. So actually from the beginning of August up to the mid-August, the 18th and 19th, and then 2 weeks the other side of that. That's when you start to get an increase in activity, and then the activity starts to slope off again as we move through the cloud of debris that gives us the display.
So in this Perseids meteor shower then, how many shooting stars might you be able to see? If you have a good night, it's all clear, you sat there in your deck chair, the weather's perfect, maybe you've got a glass of something of your choice in hand. Crisps even, I don't know, might be other snacks. A glass of crisps. If you're really, if you're really pushing the boat out and going, really going for it, a glass of crisps and maybe a drink as well. How many might you see in an hour?
A glass of crisps and a bag of drink.
That's how I do it in my house. I mean, other people's experiences may vary.
Yeah. So per hour, you'll get up to about 90 per hour with this particular display. That's with no moon in the sky. And of course, that's what we've got this year. No moon. Hooray. So up to about 90. But to see 90 per hour, you're going to have fish eyes. So a good view of the whole horizon, perfect dark skies and stuff, which is quite challenging unless you're a fish in the middle of the ocean. I think it's a great one to get out and away from light pollution to get to see, because sometimes they can be quite bright during this shower as well. And of course, this time of year is not too chilly. which is good because the other really good meteor shower of the year is in December. So that's when it's really cold usually. So not a good time to go out and look at space and stuff. But yeah, that's coming up soon. And when you're out looking for these shooting stars, you want to be looking away from the constellation of Perseus. So Perseus is next to the constellation of Cassiopeia, which is the big W shape in the sky, which is behind that cloud over there.
As per.
And when you see that, you want to be looking away from that. Oh, I saw some lights over there which look alien. Look, can you see them?
I know. It looks like they're coming, doesn't it? It's like there's the cloud in front of us, and there's a line of white light.
So this is Kinran near Bishop Auckland.
Is that where
it is? So this is that's right. That is over there, but it looks creepy as anything.
That looks like Close Encounters is about to happen, that they're about to just come out of the sky and a beam's going to come down and that's going to be it.
It's quite appropriate, really, isn't it? I think I'll take a picture of that. But yeah, so this what was I even saying? Yeah, don't look at the constellation of Perseus. Look away from it. Look. Because they're coming from that direction, so they're going to be coming towards you, and that's going to make the tails quite short. So you want to be looking away from them where they can skim through the atmosphere and more and produce a nice streak for you.
Okay, and I guess if you have got a camera and you're into astrophotography, you could leave the thing open for a bit and see what you catch, maybe.
Yeah, that's always a nice thing to do. Just do a nice time lapse and see what you capture. See if you can create a nice composite image of all of the shooting stars that you've caught that night. And we've got loads of nice examples. What you'll notice is that that all of the shooting stars that you capture will most probably be in the same direction. So if you look at something and you think, actually, that's moving in the opposite direction, might not be a shooting star. It might be that it's a satellite. And there's a big confusion that people sometimes have, particularly now with the amount of space stuff that we've got moving around us, that people think they've caught a shooting star and actually it's a satellite. There is a way of distinguishing the two, and there is a few techniques which we'll share with you on our social media to distinguish between a shooting star and a satellite.
Yes, always one to look out for. Or maybe even the space station as well. That sometimes comes into view, doesn't it? Yeah.
Super bright is the space station as well, yeah, for sure. Little satellite there, look, drifting away.
There he is, a little satellite there. Oh, we are starting to see the stars come out now, actually. Yeah. It's funny, isn't it, how when you stare up, it sort of takes your eyes a couple of minutes and then they start adjusting and the stars start popping out.
Popping out, yeah. You notice one and then your eyes jump to another one and then you jump to another one and you think, oh, actually there's loads. But there is quite a few out there. We can see part of the summer triangle right now. So that's Altair over there. That's the tip of the summer triangle in a constellation called Aquila. And then we've got Cygnus right above our head.
I'm starting to see loads of them.
We've got Cygnus right above us here where the satellite's just drifting through. So Cygnus, the swan, and this is actually where the Milky Way is right now. So the Milky Way will be coming from the north over here, right above our heads, and then going straight down towards that horizon right over there. So it is practically almost above us is the Milky Way right now. Running through that little constellation there, and you can actually, let's see if we can see. Yeah, we can see the whole summer triangle there. So we've got that star there. This is Vega, literally smack bang above our heads, and then Deneb across to the left, which forms the tail of Cygnus the swan, and then back down to Altair, and that's the triangle, which signifies summer is here.
We're definitely in summer. Well, at least the stars say it is.
Yeah, for sure.
The weather might not match the big puddles that have got all around us, but yeah. And so, yeah, and what bit of when we say the Milky Way is over the top of our heads, we see this, big dramatic picture and so on. Where we're not looking at the actual centre, we can't see that. What bit of the Milky Way are we seeing there?
So we're seeing just from the centre. So down at the south, that's just on the edge of the centre of the Milky Way. And then we're looking right around this arm outwards towards the outside of the Milky Way when we start to look towards the north. So you're looking from the centre all the way around to the Orion arm, and across out towards the outer edges of our galaxy when we get to the north there. And you'll see it gets gradually dimmer as we move away from the centre.
Yeah, it's a fascinating thing to look out for, and people can see this above our heads now throughout August, or when does it start to move?
August. So this is going to be, moving towards the central part of the sky at midnight, probably just as we start to get into August, and then as we start to tail out of the back end of August at about midnight, the Milky Way is then going to be starting to move into the later parts of the night. So at the moment, the Milky Way is going to be earlier, and then it's going to be drifting away towards the latter part of the night as we come out of the back end of August into September. But to be honest, I think that's probably my favourite time of year to see the Milky Way. And it's certainly a popular time for the observatory, and I think it's because the whole team kind of go, the Milky Way at the back end of August and into September is amazing, and then everybody books events for them.
Well, yeah, that and the Aurora, of course, as well, as being part of that also. And again, similar sort of thing, I imagine, that the pictures are obviously more dramatic than with the naked eye.
Yeah, for sure they are, but I think the Milky Way is one of those things where it is immediately obvious that you're looking at it when you see it in a good sky. So if we were in Kielder and the Milky Way was out, there was no moon out, I'm pretty confident that I would be able to stick somebody outside and go find the Milky Way, and they go, there's a band of light going through the sky there that looks like a cloud, even though it was a perfectly clear night. That's the Milky Way, yeah. So it is a slightly easier thing to spot, and certainly a more common thing to spot as well than the Aurora is. And to be honest, is it more beautiful? I don't know. It depends it depends what you're into. Depends what floats your boat. Is it that you want to think about the size of the cosmic structure that we're inside of and what it is that you're physically looking at, the mass of 300 billion suns in our galaxy? Or is it that you want to look at some gas being stimulated in our atmosphere by stuff that's come from our local sun, which kind of feels lesser impactful when you wrap it up that way, actually. 300
billion suns is certainly more dramatic.
Yeah, for sure. So and it's a beautiful thing to look at. And I think when you see it from different parts of the world as well, you get to see the different shapes, the anatomy of our Milky Way. Certainly, if you went to the southern hemisphere, you would see a definite anatomy to our Milky Way. You'd be able to see its central section and the way that it gets dimmer as you move away from that central section, and you see the big clouds of dust lanes through our Milky Way galaxy as well, which you will be able to see. Here in the UK, down towards the south, you'll see that there's parts of it which appear darker than others, and these are just big piles of dust which are inside our galaxy. And without that dust, of course, things wouldn't have formed in the way that they did, and we wouldn't be a flat, spirally kind of galaxy either. When you have lesser dust in a galaxy, it ends up being just a big ball of stars. So it's good that we have that dust. And actually, some of the cultures in the southern hemisphere, they don't look at the constellations in the way that we do. So they don't look at the individual points of light like trying to trace images from little dots on the sky. Instead, they're looking at these clouds of darkness which run through the Milky Way galaxy, and that's their constellations. In particular, the Incan culture who were looking at the Milky Way, that was their belief was that you would move through these dark patches onto the next plane of existence. And so they have creatures in the dust clouds like llamas, and actually the llama's quite graphic because it's having a baby, and there's a shepherd and there's some other stuff as well. So
it's clearing up quite nicely now, isn't it? Here where we are, it's we're starting to see the sky develop a little bit.
There's Cassiopeia, look.
There it is. You do, yeah. I mean, obviously you're doing this every night. You know exactly where the stuff is night to night, but there it is.
I actually forget sometimes as well. Yeah.
You just say that's where it is and just go with it out of confidence.
I kind of look for key markers because I forget what's out at different times of year, and sometimes when I'm not always at the observatory every night and it's clear every night, I kind of lose track. So I look for different markers so I know that those constellations are there. I know what I'm going to be able to find over there, and I know what I'm going to be able to find over in that section over there as well. I mean, there's only 88 constellations, not a massive amount of constellations to learn, but it does take a little bit of time to recognise them, because they're bigger on the sky sometimes than what you envisage when you see it in a book. I remember that when I first started working at the observatory, and I'd been able to spot constellations on the sky in a light polluted area, and then I went to a non-light polluted area and I was lost. I didn't know it. I did so many stars. I was like overwhelmed by the amount of stars trying to find different constellations. But yeah, it's just a repetition process if you repeat it. There's another little satellite there, look.
Oh, I see that one. Yeah, drifting
you can
through.
see quite a lot of stars inside of the summer triangle there as well now.
Yeah.
And you can see the whole of Cygnus. So we've got this lovely crucifix-like shape where this satellite is drifting through.
Yeah, this is right over our heads, by the way, straight up.
And that, of course, is the long neck of the swan up to that star there is called Albirio. And people used to think this was a binary system because it's two stars, actually, when you look at it through a telescope.
Okay.
But it is not a binary system. So binary system means two stars going around each other. This one is actually just two stars in a very close proximity to each other from our perspective, but there's about 80 light years in between the two. And they are two different colours as well. There's a yellowy one and a blue one. And that makes
it 80 light years apart, even though they look next to each other.
Yeah, they look next to each other, but 80 light years apart.
80 light years?
Yeah,
that's
quite a distance, really, isn't it?
Well, that's what, further than our entire solar system by a long way.
Way bigger than that. Yeah. I mean, our nearest star.
That's like calling. That's like saying Neptune is way closer than those two are together, but yet they look side by side in the sky.
Yeah. So they're. So I mean, our nearest star to us is 4.5 light years away.
Right.
So if you got 80 light years away from our sun, actually, you probably wouldn't be able to see it if you were on a planet around another star. That's how distant that is away from each other.
But they must be massive stars.
Yeah, they're
absolutely. Compared to, by that token,
they're probably big and bright. Yeah, certainly the big blue ones probably very bright and
compared to the sun, I mean.
Big. Yeah, for sure. It's going to be huge. I'm not sure how big they actually are. I think we do have probably a steer on an approximate size or mass of these objects, but. So those are quite far away from each other and quite far away from us as well, about a couple of hundred light years away from us, those stars. And then Deneb at the back here is a lovely big bright star as well. Vega's a lovely big bright star.
I think I just saw a little shooting star.
A shooting star.
Yeah.
And then Altair's a lovely big bright star. Let me just quickly check something.
There was definitely a little flash of light there across. I find the whole, light travelling thing fascinating. That we're looking at stars there that are 200 light years away, and that, that light's been travelling since, the 1800s, and it's just got to us
America
now.
Was a thing, maybe.
Exactly, it's older than America, and it's that little speck of light has travelled from then, and it's only just reached our eye now.
What I like to think about with that as well, and people often say this to us at the observatory, we'll get it on feedback, and it's one of my most vexing pieces of feedback that comes through. Not that I want to turn this into a feedback rant. but
here it comes.
Here it comes. But one of the things that really frustrates me with feedback is when we get the feedback which says it would have been nice to see this stuff on a screen. When it's a clear night and we're showing people stuff through a telescope, and I get what people mean. I think what they want to see is the drama in these things rather than looking at it with the naked eye, or the ease of seeing it on a screen. But the thing is, you can do that on YouTube at home.
Yeah.
If you come to an observatory, what we're going to do is we're going to put your eye up to an eyepiece, and the reason why we do that isn't just because we can, it's because that is a human connection with the universe. When you're looking at light from these objects that are above our head, although they look like these little tiny dots of light, that light is still physical, and it's still a thing which is travelling through space, these little photons of light which are produced by those stars. inside those stars due to the nuclear fusion that's happening inside them. So that nuclear fusion is producing that light that's been ejected from the star. That light then travels through the universe, and then you look at it and you capture that light with your eyeball, and then you turn that into the electrical signal, which gives you your vision. So you're absorbing a piece of light, which has actually travelled 200 light years or so in that case. With Vega above us here, this is 25 light years away. So Vega, 25 light years away.
Yeah.
Altair.
I weighed a bit less then.
Yeah. Actually, interestingly, 25 years ago is when the film Contact came out as well.
Oh, of course, yes.
Which was about Vega. So they're probably getting that film right now.
They're just realising that it's a great film. Just released, having the premiere now.
Altair is 16 to 20 light years away from us, so it's a little bit closer. And Deneb, the other one that we saw that's now gone behind the cloud, although all three are very similar brightness, Deneb is 1,500 light years away.
Wow. I mean, there's so much that's gone on in that time.
A lot.
I mean, yeah, it is fascinating. And that's it. Is that personal experience? And it's like you say, you can show it on a screen, but it's all about you putting your eye up to the eyepiece, and you are capturing that bit of light in your eye that's travelled for 1,500 years through space to your eye, not to everyone else's eye on a TV screen. So that's part of the point, I guess.
100%. And it's actually a dying art in astronomy as well, because we want to take photos of everything. And we want to capture stuff and keep it and share it on social media, get the likes, whatever. From a scientific perspective in astronomy as well, it's lesser to produce beautiful images. It's more to collect data. So actually, sometimes you're not even seeing an image. You're just getting some data from whatever it is that you're looking at to plot a graph.
Two more Ford Fiestas.
I think that was the Fiestas that went.
Is that the same ones?
Yeah.
They look like finished their race. They're sort of meandering back.
So in astronomy, in scientific astronomy, capturing data and not looking at images, so none of these new techniques or new ways of us capturing the night sky are us looking through an eyepiece like we had done for hundreds of years, which opened up the discovery of all of these things that we've seen in the past. I mean, Patrick Moore used to be a great advocate for drawing what he saw through his telescope, and that was, of course, the art which people did for hundreds of years. Isaac Newton did it, Galileo did it, all of those people leading up to the mid-1800s were sketching whatever it was that they were looking at through their telescopes.
That was going to be my next question, really. You know, what did these astronomers do back in the day before? Obviously, they didn't have Facebook to sort of to shout about it. So I was going to say, is that what they did? Just write it down, draw about it, and share it that way.
Absolutely, write it down.
Likes and shares have never changed, though, have they?
No, they definitely haven't. It's just the way that we've shared it. It's has changed slightly, but yeah, they would sit and they would sketch. And it's funny because when we get people at the observatory who are looking through a telescope, they may do the quick, like, boop, I'll just have a quick look, boop, and then you're like, oh, you're done already. Whereas people like Galileo would have spent the entire night dedicated to just looking at that one object, and it was that dedication which revealed more details about an object. In particular, places like Jupiter. When he was observing Jupiter, he realised that over the course of the night that dots around Jupiter were moving, and he thought, oh, what's going on here? These could be things going around Jupiter. Could they be not too dissimilar to our moon going around us? And so all of these things come from us observing for a long period of time and trying to collect information from it and sketching it down as they did in this case, and then sharing that through journals. So publishing those journals, sending them to the scientific community. And that's how word spread back then, I guess.
There's more to see this direction now, I guess, towards towards the west?
Yeah, towards the west. So we've got the plough there. We can see the handle of the plough.
The classic plough. There he is.
And we've got Arcturus over here, big red star in the constellation of Bootes. And then upwards towards up here somewhere, we've got the North Star up there. Where is it? It's behind that cloud there. There it is. It's gone again. It was there, but it's gone. So that's going to be north right there.
Right, there we go.
There you go. We did some navigation.
There you go, old school. Get the old sextant out and away we go. And the moon blocked out by the cloud at the moment as well, which helps.
Yeah, that does help. It actually gives us a little bit of a better view of what we're seeing. I love this patch of sky over here. This is not a constellation, but it's one of my asterisms. And I call it my asterisms because I've never seen anybody else call it this before. But at this angle, if you look at where Arcturus is, the big bright one, there's a star right above it. And then there's a star to the right at about the 2 o'clock position and a star to the left at about a 10 o'clock position. It looks like a flux capacitor.
It does. I was going to say a Y,
yeah.
But yeah.
So I this is the flux capacitor asterism. So there we go.
Fantastic. Yeah, it looks like, if the cloud moves away, you'd get a good night tonight, definitely. But still that little bit of cloud knocking around. So other things then, anything else to watch out for through the course of August? Because this is going to be the podcast for I guess, just leading into the start of August, and people hear this, and what else should they be looking out for?
Well, I think the biggest things to look out for are going to be things like the Milky Way returning, dark skies returning, and the Perseids meteor shower. And actually, I've just spotted something just where this thing over here is, I'm the astronomer, yeah. Yeah, the plough. Cut. So the plough. When you see the plough, the three stars in the handle of the plough. The second one in, it's 2 stars there. You see this one quite faint. You can actually probably measure how good your sky is by seeing those 2 stars. So if you see those 2 stars, you might think, oh yeah, I've got quite a good sky here. Actually, I can see 2 stars there.
So the 2 middle stars and the handle.
Yeah. One of them's quite dim. These are called Mizar and Alcor. And actually, one of them's a double star. It's quite cool. Through a telescope, it's 2 stars orbiting around each other. Actually, I think it's 4 stars orbiting around each other, but we can only see 2. So.
Okay, so that's one to look out for. If you've got a perfect view of the plough, though, you're in a good place.
Yeah.
As far as Kielder Observatory is concerned, you've got plenty of stuff coming up through the course of this time of year. As you say, very busy time of year. School holidays are on. Yeah. Plenty of kids' events. And in our next episode, I'm basically leaving my daughter in charge. She's 6, nearly 7. Very keen to point that out. She is. And I'm going to bring her to the rockets, one of the rockets sessions. And I'm just going to leave her in charge and see what happens. What could possibly go wrong?
Who knows? Everything. As long as we end up with launching rockets at the end. In fact, actually, was it last weekend or the weekend before? It was absolutely bucketing it down. But the dedication of the team during these events is just admirable. Liam and Guy, they were out there in the absolute teeming down rain, dedicated to launching rockets, and they did that. So whatever the weather, within reason, I would say, as a caveat, we'll be out there launching rockets and doing some other stuff as well. If we can see stuff through telescopes, then of course that's something that we'll do. We can see the sun. We've got sun specs for our telescopes. If that's out, if not, then we might be able to see some stars, some brighter objects, and certainly we'll do some other activities as well. Look at the rocks and things. Yeah, for sure.
Well, if nothing else, she'll be able to tell you all about Henry VIII, which seems to be her thing at this moment in time.
Favourite thing, yeah.
So, we can always fill the time with that. If nothing else. There's Hercules. Hang on, stop press. Here's Hercules.
Can only see half of him, but these 2 stars on the edge here, these are 2 of Hercules. You can just about make out the rest of him, but he's a bit dim. And you might be able to see this curve of stars. There's a bright star just there, which is actually the left-hand side of the flux capacitor. So this is Corona Borealis, the northern crown. It's a curve of stars like this. Looks like a crown.
There you go. Corona Borealis.
I tell you who the best person is for these things. It is Monk. When he was a kid, he digested a book on stars, and it just seems to have stuck. So you can ask him star names, he knows them, and you can ask him how far away they are, he knows how far away they are. It's just got to commit to memory, but my memory is just too fluid for that. I keep replacing it with other bits of information
that come and go as required.
Yeah.
The message from this podcast then is that, well, you don't have to go too far to find somewhere with dark skies, and you can usually do that for free. You don't. Obviously, we encourage you to come to Kielder Observatory as much as possible, but that isn't always possible. And for those occasions, then get out there, get looking up, find somewhere away from the light, and you might not have to go very far. Plenty of places around the northeast, both on the coast, but also out where we are in the middle of nowhere, which seemingly looks like on the moon, but just above Durham.
Even though the sky is still blue over there, where the sun set not too long ago, you can still see quite a lot of stars. I mean, that is quite a dim constellation, that over there. Perseids is quite a dim constellation, but we can see all of Perseids right there, even though there is a car behind us with its full beams on. So there is some artificial light pollution around us as well. But yeah, it's a great place to come, this, actually. It's a great place for an observatory, but it's too windy.
It is a bit breezy. I mean, we're stood behind Dan's car, to be honest. I've just looked at those headlights now and I can't see anything. But if I move over here, you'll hear how windy it is. Take the wind filter off. It's been like that the whole time. Rule number 1 of astronomy is wrap up warm. Regardless of the time of year, it's always going to be pretty cold if you're going to somewhere fairly remote to look at the night skies. So take your big coat and you should be good. And we were up towards Wascally there in County Durham, not far from Derwent Reservoir, but there's plenty of places that you can go. And at this time of year, it's just a case of looking up to see the Milky Way, the Aurora, and also we've got the meteor shower coming up through the course of August as well. Find out the events that we've got available through August and in towards September, and indeed for the rest of the year, at kielderobservatory.org. Book in advance. Get your places booked now, and we hope to see you at Kielder Observatory very soon. A good spread of events, quite a few kids' events going on as well through the course of the school holidays, but also our regular events, including late night discovery for the real late birds. Those sessions begin at midnight and go into the wee small hours. We've also got sessions covering the topics of astrophotography, the Aurora, the jewels of the universe, the origins of the universe, and our moon. Just some of them. Find out all about those. kielderobservatory.org, and we hope to see you soon. And in the meantime, happy stargazing.